Okay, today I'm just going to cover how you can create TriSCAN graphs showing the volumetric ion content, but only at the same moisture content. So what we're going to do is filter out all the VIC readings that aren't at the same moisture content. And there are two criteria here. One is to get the same moisture content at or below field capacity, so we're not getting any of that kind of turbulence that can happen in the profile and interfere with the reading. And the other one is to make sure that it's, for the same reason, it's only on the downward slope. So we don't actually take a common soil moisture reading at the upward, when the slope's going upward, because that means that you're going to get turbulence. So we only look at it at the stable side of the graph when it's actually drying out. Okay, so let's go through the process. Selwyn's created some neat little features here that make it quick to do. So if we click File and New Graph. So what I'm going to do is I'm going to browse for a particular database, which is this one here. And in this database, what I want to do is I select soil water content, and I select the layers that I want to create the graph on. So for example, in this particular case, let's just look at the action in the first three layers, but you could have all of them. You could make all 6, you could make 4, you could do whatever sensor selection you like. And now, instead of saying summed, what you do here is you say VIC filter. And what that's going to do is it's going to create a common Y soil moisture graph at the bottom, in the bottom pane, and then in order it will create those three levels that I ticked, which in this case is the 5, 15 and 25 centimeter level, and it will display those in order with their volumetric ion content unfiltered at this stage. So I click this feature VIC filter and I create a graph, and there you can see in the bottom pane is a common Y graph, so that it's easy to determine this common moisture content where where the moisture is at the same level where we're trying to screen the data from, and then 10 centimeters, 20 centimeters, 30, or should we rather say 5 centimeters, 15 centimeters, 25 centimeters, because of course the sensor is in the center of each 10 centimeter span of moisture. Okay, so then I don't want to look at the previous one. This probe was moved, so I'm just going to first of all zoom in just on this period of time from the 16th of October to today, and I will do that by just clicking and holding. Okay, click and hold. So what that'll do, it'll zoom in just that period for me. Okay, so we can see that nicely here. Okay, now the second thing I want to do is I'm wanting to determine the moisture content. Now it's not very clear here because this is a very small graph. So a tip is to go up to your graph function here and say change pane heights. Okay, and if you click on change pane heights, now as you know from any of these features, you get that yellow bar at the top, which means that that feature is now active. Okay, and whichever pane I now click on will become bigger. So I'll just click on the bottom one on the soil moisture pane until I make it big enough to work with. Okay, so I've now got it big enough to work with, and I can really see what's going on. Okay, so that's my first step. Now it's really a simple matter of selecting a common soil moisture content for us to make comparisons on. So let's start at the top. So I go up to that first pane, which is at 5, so the sensors at 5 centimeters. So we're measuring from 0 to 10 at the surface of the soil, the volumetric ion content or the ionic activity in the soil water, and I'll right click it and I'll go VIC filter. Okay, I can either type a value in there, or what I'll do is I'll go pick value. So I go pick value, then I go down to the moisture graph. Now we can see that that particular pane is black, so that corresponds with a color, and that is also the 5 centimeter. So the black soil moisture is the one that we're looking at graph. So now if we look here, okay, there's been some recent activity there. That's all very saturated, so we can't make a comparison up at these higher levels, but we can do it here. So if we go around about this point here, I'm really looking for one common point that's got a lot of intersections. It intersects in a large number of points. So I'm going to select that particular point, and it clicks it. That happens to be 5.039 millimeters. You can tell by that number, obviously, that it's a very, very sandy soil. Okay, growing potatoes. So if I say OK, now you can see it's beautifully screened all that data, and you can see some dynamics, which we'll talk about once we've got all the panes screened. So let's go down to the second one, and we go Vic Filter, and again I go Pick Value, and I go down here. Again, that's very saturated up there. They've just done an irrigation. I come down to a common denominator point around about there. I'll click on that point. In this case, 6.368, slightly more moisture, which is often the case. As you go down a profile, it tends to hold a little bit more water. Press OK, and there's the dynamic at the second layer. And again, similar thing, third layer, Vic Filter, Pick Value, come down to this point here. Again, if we go there, we're going to miss too many points. You see that even though on the 17th of November, it'll give me more recent data. You could choose that. But then, of course, you lose some of the information that you got. Or maybe we'll do that because we actually want to know what's happening now. It's not much use doing this and knowing what happened last week. Okay, so we'll click on that. And in this case, it's 3.643. And I go OK. And you can see how that's screened. So it gives you a bit of a trend. Now let's go back to our graph and our change pane heights feature. And in this case, I'll go back and make all panes equal. You see, I've got my cursor here, make heights equal. So I click on that, and now we can see a bit better what's going on. So let's have a look. I'll stop that feature, press the cross, it stops that feature being active. And you can see what happened is right about the 20th of October, there was a fertigation event. This was a fertigation, and it came in with some fertilizer. You can see it rose the level right up to about 5,000 Vic units. And then it got used up or washed down with the various irrigations that happened down to a base level of about 2,000. The next layer, you see it picked up to around about 3,000, and then it got worked down again. But even this bottom layer seemed to also pick up, and you can see the moisture reached there, and you can see so did some of the fertilizer. Okay, but it maintained that level at around about between 2,000 and 3,000 at the base. Whereas at the top we have a lot more dynamism as we go through the fertigation cycles. But you see an increasing trend here, a little bit more of the fertilizer accumulating down at the second layer, and a little bit even coming down to the third layer. If we really wanted to make sure that we weren't leaching anything below our active root zone, we would have chosen some more sensors below that to check that we weren't leaching anymore. Okay. Thank you.